In this section, we're going to translate words into symbols. Many of these you already know. There's a couple that we're going to have to be careful about. So let's look at some examples. 5 more than a number. We don't know what the number is, just some number, so we're going to use a variable to represent it. We can choose any variable we want. Now when you do your problems in my math lab, it will often tell you what number to choose. It will tell you to choose X or N or T or whatever. But if it isn't in my math lab, you can choose whatever letter you would like. I'm going to choose for this one N. So 5 more than means what? Add. So 5 plus N is the expression that represents this sentence. Okay. This one's a little trickier. 5 less than a number. Now think about when you do less than. If you have $50 and I have 5 less than you, I don't do 5 minus 50, I do 50 minus 5. So whenever you see less than, you're going to have to reverse this. So if the number is N, 5 less than N, it's going to be N minus 5. So you need to do it in the other direction. That's kind of archaic, old-fashioned language, but you may occasionally also see 5 less a number. Notice the word than is missing. It's just 5 less. That means just subtraction. That's similar to the more than. That's when you would do the 5 minus N. But like I said, that's kind of old-fashioned speech, and we don't really use that very much anymore, though you may see it in a problem somewhere. Okay, what about 5 times a number? 5 times a number would be multiplication. So I'm going to do 5 times a number. Remember, you can write a letter next to a number, and that means multiplication. So I can write it without the dot if I choose. Okay. We get confused with the less than. We might sometimes also get confused with the into and the by. 5 divided by a number and 5 into a number. Two different examples here. So 5 divided by a number would be 5 divided by n, or more typically we write them as a fraction, 5 over n. Because it's a variable, I wouldn't write it this way, but if you write it with a traditional division, 5 divided by a number would be like this. So the second number after the division is the same as the number under the fraction bar is the same as the number in front of the long division symbol. Though the answer to this question we would want to be in this form. 5 into a number would be the other direction. 5 into it, which makes sense with the long division symbol. But we're talking about writing it as a fraction or division. Okay, so be careful with the less than and 5 into symbols. What about twice? Twice a number. Or the other one that goes with that is half. Half of a number. Whenever you see of in a sentence, it usually refers to multiplication. We're talking about numbers. So in this one, twice a number would be 2 times the number. Half would mean half times the number. So if I'm going to use x for my number, half of x, which can be written a couple different ways, half x. The x can be down by the bar, or you can have the x in the numerator, because that's really x over 1. Just a couple different ways you could write half of a number. And then it means times. Okay, let's combine a couple of these. 3, too many r's there. 3 more than twice a number. And this time let's make the number y. So if the number is y, 3 more than y would be 3 plus twice the number, so that's twice y, 2y. Okay. We'll do this one, and you pause and write down your answer before you start again and see if you've got the right thing. 6 less than 3 times a number. Let's use B for the number. Okay, see if you can write it down. Okay, less than, remember we have to go in the other order. So that's going to be the 3b, then the minus 6. So remember, because of the less than, we've got to reverse it, turn it around. Okay, another thing we need to be careful with are the words sum and difference. Sum is the answer to an addition problem. So when you see the word sum, think about a plus sign inside of parentheses. When you hear the word difference, difference is the answer to a subtraction problem. So think about the difference inside of parentheses, a subtraction inside of parentheses. The same is true with product, which is multiplication, and quotient, which is division. But it's not as important for those because order of operations puts multiplication and division ahead of addition and subtraction. By using the word sum and difference, we're saying we want the addition or the subtraction to go ahead of the multiplication and division. So we're changing the order of operations. We need to indicate that with parentheses. So let's look at an example of that. 5 times the sum of a number and 3. Okay, so I'm seeing the word sum, so I'm thinking parentheses with plus. Sum, what kind of a sum? Of, that's the preposition telling me what the sum is. These are the two things that are getting added, a number and 3. So that means I need the number, which we'll use x for, and 3 to be the sum. So the sum is x plus 3 in parentheses. And now the front part, the 5 times. So I get 5 parentheses x plus 3. And then if you want, you could simplify that by distributing and get 5x plus 15. Either way, those are both good answers. Okay. Let's get an equation. See if we can solve it. 5 less than a number is negative 8. 5 less than a number is negative 8. When you see a number sentence, of, I said, means multiplication, is means equals. So we're going to put equal signs for the is. 5 less than, remember the less than, we're going to use that in the opposite direction. So x minus 5 is equals negative 8. And how do we solve this? I'm trying to get x alone. So we add 5 to both sides. This gives us x plus 0, or just x on this side, and negative 3 on that side, so the number is negative 3. And you can actually replace that in the sentence. 5 less than negative 3 is negative 8. I'm going to test that it works. Okay, let's look at an example where something like this could be used. Let's suppose you had a cell phone deal. We'll decide whether you think it's a good deal or not. Let's suppose you had a cell phone deal that charged $20 per month plus 8 cents per minute. Okay, your budget allows $55 a month for your cell phone. So how many minutes can you afford to talk? Minutes per month, I'll say. Can you talk? Okay, well, how many minutes do you talk? We don't know, do we? That's the thing that's going to change or vary. So this is the thing that we're going to use as our variable. You can talk X minutes per month. So how much would that cost you? Well, I always have to pay the $20. Plus I have to pay 8 cents for each minute. So if there are 5 minutes, that would be 0.08 times 5. If there were 20 minutes, it would be 0.08 times 20. Well, we have X minutes, so it would be 0.08 times X. The total that we can have is $55. So now we have to solve this equation. We'll subtract $20 from both sides. This comes out to be 0. And on this side we end up with what? $35. And so my last step is to divide by 0.08. Of course, these 8s cancel, give me a 1. Let's see, 0.08 into 35. Leave the decimal. 8 times 4 is 32. 8 times 3 is 24. And 8 times 7 is 56. So I'm going to round off. It's approximately 437 minutes per month. Oh no, that doesn't sound like a great deal. $55 for 437 minutes. That's how we would set that up. Okay, let's look at another one where we would have 2 different answers. Bob has 20 more baseball cards than Fred. Together, they have 55 baseball cards. How many does each have? Okay, well, I'm going to have to say Bob and Fred. Who has more? Bob has more, so Fred has X, or whatever variable. Bob has 20 more than that. Let's add that together to see the total. The total they have is 2x plus 20, which equals 55. And we need to solve this. So I'm going to subtract 20 from each side, giving me 2x equals 35. Uh-oh. Somebody must have some torn cards, because X turns out to be, what, 2 goes into there, 17.5. So that would be Fred, because Fred is X. And add 20 to that, 37.5. Must be Bob. And that's kind of silly that they would have a half one, but that's how that turns out. The last section for homework 3 will be on the linear inequalities. Inequalities meaning not equal to, greater than, and less than.